Hello, everyone. You guys can hear me, right? I shall try explaining what really happened. Everybody has a view of what happened. Oh, how do we do? Click. All right. So, why is it not working? Yes. Sorry, guys. So, last week, what happened was there was a massive distributed denial of service. I'll try explain every bit of it slowly and steadily. So, the way I would describe this is like in your city that you live, you had a massive traffic jam. Okay? You're never able to get to the place you wanted to go. It's as simple as that. In a physical world, if you had to have a distributed denial of service attack, there are a bunch of guys, imagine all the taxis in the city, they decided that they're not going to allow anybody the use of the roads. And they're just going to drive very slowly and block every road in the city. That's the simplest way to describe a distributed denial of service attack. So this was pretty interesting because the scale at which this was happening was so massive. So the distributed denial of service attack is not happening the first time. We've had a whole bunch of them happening over time. And this was quite unique. OK, this is just describing the typical distributed denial of services. So it's like you have like, when I was talking about the taxi thing, imagine that there's one person who actually manages a bunch of taxis. Okay? So the attack happens something like this. You set up like a bunch of websites. I mean, this is attacking normal machines. So you put some malware onto each of those machines. And this was slightly different, OK? I'm just describing a normal one, and then I will describe what happened last week. So you infect the machines, and now you have a whole bunch of cars, OK? You have cars. Now you need somebody to manage the cars. So those are the handlers. The handlers would actually manage the cars, OK? They will tell them which road to block, OK? And once you have that as a layer above that, that actually manages the whole attack, OK? This is how it should happen if you were to do this in Berlin, OK? You find all the cars, all the taxi drivers, you convince them to join you. Now, there are local people who will be actually doing that. They'll be the handlers, and then you will have the attacker who sits above it and actually does the stuff. OK, this time, this was different. Why was it different? It was massively amplified because of all the IoT devices. OK? And this is a classic case of tragedy of commons. The reason I say that is like there's no incentive for anybody to secure their IoT devices. Can I have a show of hands? How many in this room actually have an IoT device like a camera in their house? Just show of hands. Don't be afraid. Please be honest. OK, now, if you have changed the password since you bought it, oh, wow, I'm impressed. OK, right. So generally, people don't do that, OK? And this is a massive problem. So what happens is like you write a script, and you go through, and pretty much security in the IoT space is a non-existent entity. So security always comes at a price. It comes at the price of usability, generally speaking. So anything that's super secure, as you would recognize, is pretty hard to use. So you want to make it really simple so that nobody would actually make a mistake. So if nobody makes a mistake, what happens next? It's so simple to attack it. And that's exactly what happens. So you have a very large number of vulnerable endpoints. And all you need to do is just go out there, get them together, ask them to do stuff. It's so easy, right? You don't need to convince anybody. They're all, think about Berlin with a set of all taxis that are willing to listen to you. You just walk up to them and say, guys, I want you all to go just block everything over here. Done. And that's exactly what happened. So now, what's the definition of cybersecurity? I think if you were to actually look at it from a very physical world, you pretty much would agree that it already existed. You assume this to be true in your physical world. You don't, everybody actually has a concept of ownership. So if you own, say your pen, your phone, you wouldn't expect anybody to walk up to you and take it away from you, right? So, the same concept, if it happens in a virtual world, that's when, you need very sophisticated definitions and things of that sort. And we tried to map it, and we call it cybersecurity. OK, so let's look at what's been happening. I've got a graph over here just showing the amount of attacks. And one thing you would notice is that the attacks have increased. And the volume and the traffic that's been generated has increased significantly. The reason I say this is this, right? If you look at the internet, there's a very, very large economy that actually thrives on the internet. So anybody attacking the internet using a distributed denial of service attack, there will be people willing to pay a premium so that they can have an amount of assurance against a distributed denial of service attack. And all these guys were taken over, meaning all their bandwidth was like totally used up. So everybody who is actually a serious player will actually have some bandwidth allocated so that they can actually take on or reflect a distributed denial of service attack. And all these guys were like taken out massively. Okay, and I'm going to talk about, try the data angle to the whole thing and just try to describe what's been happening, give you like a flavor of what's happening, the new developments in the ecosystem, and how probably machine learning and AI could actually be somehow helping the people fight the fight. So cybersecurity it's like a war, an ongoing war, okay? It's like this. You have something that everybody else wants. In a physical world, if you live in a house, your house has a door, it has a lock, you have a key, only you have the key, okay? Now, if you're in a virtual world, the problem is slightly different. You don't actually have a lock, and you don't have a key, and if you have a key, it's pretty easy to copy keys. Copying in a digital world is very, very easy, and that's one of the problems, that's the biggest problem, literally. So it comes down to who has the ability to attack something on a very regular basis, or who can put in enough of effort to overcome the defenders. And it's actually a real battle between, I would say, a battle of wills and battle of wits. So battle of will in the sense like, how long will I be able to, resist against a persistent attack? And on the other side, it's like, how much resource am I willing to spend to defend it? So I just thought I should talk about ransomware. Ransomware is quite simple. What happens is, literally, you go to a website, you don't even notice anything has happened. One fine morning, you go to a machine, your machine says, oh, all your hard disk has been encrypted. Now you need to send me an amount of money. If you don't send me that amount of money, your hard drive is going to be wiped. And there's a very interesting sub-story to this. That the fact is like the cryptocurrency bit, right? So if you look at any of the cryptocurrencies, any of the malware, most of them ask you to pay in Bitcoin. I know this sounds interesting. Well, you could probably say, well, Bitcoin enabled them to do this. But they would have found other ways to do it. But it's interesting. It allows them to actually do this. You can actually have like so many massive, how could I describe, networks of ransomware sites hosted, managed, and then collect the money via cryptocurrencies. So it's like a near-industrial mechanism. You can have an infrastructure, the cost is minimal, people pay for it. Even if your hit rate is like your all statistician, so you will understand. Even like less than 2%, right? Even then, they make serious amounts of money. The average calculation for an operation is like 60 million, right? For a year, $60 million. So that's serious amounts of money. They would definitely attract talent, right? Whether it's good or bad, when there's money, there's opportunity, people go in. Okay, I'm not going to go through the whole bunch of it. Yes, I will talk a bit about the dark web thing. There's a reason why I want to talk about it. So whatever that normally happens in the normal world happens in the virtual world, right? So in a normal world, we have police and other things to prevent people from doing silly things. And they control normal markets where you can sell and buy things. So imagine you want to attack somebody, buying a gun is illegal. Then you go to a black market. So similarly, if you actually want to attack somebody, you want to get a zero-day exploit. So can I have a show of hands? Who here understands zero-day exploit? OK. For the rest of the guys, zero-day exploit is an exploit of a software that's not published, but is known to community, some people in the community, especially agencies which are three-letter, it's like NSA and other people, people starting with M. They buy these, and they use it to attack people. So things like that, they could be bought and sold on dark web. And the thing is, like, this is more interesting. This is one thing I always say about cybersecurity. Every time technology is introduced, one of the people that makes the most advantage of technology are the people who are, I would say, a bit more malicious, right? They see it an opportunity. So the moment we actually use Tor, create a dark web, what they see is an opportunity to buy and sell malware and do stuff. So the best example is this one, and I'm sure everybody will recognize, right? Yeah, you probably all followed Silk Road on the news. I'm assuming everybody has, so I don't have to explain. So this is a very interesting example. So it's like everything was bought and sold there. And now I probably should say about smart contracts, because it's very interesting. It's very interesting in the sense like anything you wanted to do until now, where you had to actually have trust with another party and actually had to write a contract, it's all going to disappear. You can actually have a smart contract. I mean, I'm not going to describe smart contract, but for sake of completeness, I just put it there. So, imagine this. Imagine this ransomware problem, right? You can actually have a smart contract. And you can actually have a distributed set of agents that are actually working in your enterprise and controlling over your enterprise. And the contract would actually present yourself with a challenge. And the challenge could be, give me 2 million. Else the whole enterprise is going to be wiped. See? So this is the thing that we are seeing in the so-called cyberspace, the cybersecurity space. Whenever new technology comes in, it comes with both sides of the equation. One side of the equation is we have a lot of value. We can actually have decentralized trust. We can actually do disintermediation. At the same time, that gives us very interesting opportunities, right? So you can have an assassination market. Sorry, this is interesting. I thought I should mention it, but I'm not suggesting anybody do that. But you could easily do that. It's so easy. And the other thing is like, one of the things you would notice that would be pretty hard between criminals is it's unlikely that they would trust each other, right? They pretty much want to kill each other. Then how would they trust? Now, this is the best part about Bitcoin and blockchain kind of technology. You can actually do things without actually having trust. So which is like brilliant, right? So this makes our world even worse. So that gives them an ability to actually collaborate on things which they were never able to do before. All right, so now there's a question of the advanced persistent threat. Pretty much, I'm sure everybody might have heard about it. So this is like you really want to get into an enterprise, you want to go through it, and you want to find stuff that's really valuable, okay? There are some nation states, I'm not going to name them, but you all know them, and they are really interested in various industries, various sectors of industries. And what they do is they go for things, and they would actually do spear phishing, like literally figure out who is who, send them an email on, connect them on LinkedIn or attack their phone, and then through that, get into the enterprise and get the stuff out of it, okay? And the thing that's most interesting is two parts, right? So the two parts that are most interesting is the fact that you would probably recognize the exfiltration very easily, because you guys are all data scientists. You pretty much see some anomalies happening. And the other part that's actually happening is this mostly capture. When they try to do the capture, there will be telltale signs. And I will try explain this slightly better so that you guys get an idea of what I was trying to say. So when somebody attacks your enterprise, what happens next? You'll have a whole bunch of problems, right? So the enterprise have been looking at this for a long while. They have been looking at SIEMs. This is like a traditional thing. Think of it like a rules engine. Whenever something goes wrong, they go, hey, somebody's knocking the door, kind of thing, okay? And then, slightly more sophisticated ones, so that you applied a bit more statistics to it, right? And then that was like, okay, if somebody knocked the door more than 10 times, oh yeah, this guy is really not good. He always knocks. There could be something behind it, right? And the thing that's actually happening is actually that improved the whole thing is the whole introduction of the machine learning and AI part to the whole thing. So you could actually see trends happening. You can actually start predicting things and see, oh yeah, there's a high probability this particular cluster of machines that are there could be malicious. So it's like you would probably do just plain clustering for a whole bunch of things, and you see, a cluster moving away from the norm. This could be geographic. For example, if you don't expect somebody to log in from some server in Russia or in China or some other part of the world, if the IP turns out to be a different one, you go, oh, this guy is supposed to be in Berlin. How come this guy's IP is now mapped to some place in wherever it is, right? So that's an anomaly. So, oh, sorry, okay. So this is like a very, very simplistic way of looking at, how we could actually flip the whole problem on its head and see if we can actually come up with ways by which we could defend an enterprise from the bunch of guys who have so many new and interesting tools, as I would say, to actually attack us, right? So, using analytics and data science to see the attack patterns that are emerging, the attacks that's actually starting, the attempts that are being made, and seeing if we could actually get a better response for the society towards this attack. Yeah, the rest of it is all stuff for people who are like fluffy. So the summary for anybody is this. Security ecosystem has been moving at a very fast pace. And I'm sure every bit of it is always improving the ability of people to attack, right? Emergence of IoT. See what happens? You have more and more endpoints, okay? There are more and more endpoints coming out. So the more endpoints you have more, it's just a probability distribution. Even if it's 10% of something, the larger the pie, the larger number of vulnerable endpoints out there. And there is some hope out there in the shape of machine learning and stuff like that. And in the future, what I suspect will be a battle of algorithms. In the sense, like, I suspect in a very short time from now, the so-called adversaries would actually have access to enough of machine learning and enough of expertise to actually start. I haven't seen it happen yet, but I would say now that it is very likely they would start scanning, but pretty much automate the whole ecosystem, right? So you start everything in the whole world, look for all the ones that are like low-hanging fruits, which are connected to the right place, connect to them, you can have a whole selection of attack tools you can have. You can have a ransomware, you could just bring it down, or you could do denial of service for a charge. These are all things that you can actually buy. You can actually buy denial of service attack. So there are some people you just say to them, okay, I want to do DDoS for this IP for this amount of time. They will give you a price, and you pay the price, and they will knock it down. Okay? So that's the future. A battle of algorithms. Okay? And yeah, my favorite guy, he says, he's just already there, not very evenly distributed. That's it. Done.